Hey everyone, welcome back. This is lesson 5 where we're going to learn about data abstraction in Python. Remember, data abstraction is the idea that you can use data to represent complex ideas and complex amounts of information in simple ways. In today's lesson, that means we're going to be using lists. Let's get started. When we talk about data abstraction in this class, most of the time we're talking about lists, because a list is a way to abstract a concept and represent it as a single variable, right? So for example, a list of names can be just a list of names, but it can also represent the students in a class, so like the roll call for a teacher. It can also represent a shopping list if these were food items. And so that's what we mean when we say data abstraction. We mean that by consolidating all of this information into a single variable, we are basically taking a lot of information and representing it in a more compact format. So in this case, we're talking about the players in a game, and we're representing all the players on a list, all of their names. In Scratch, this is what a list looked like. You had to declare the variable, and then you added names to that list, one with each block, and then here's how you would repeat through and add things to that list. So you could actually use repetition to also add items to the list. In Python, creating a list, you would give it a variable name and then set it equal to, and then these empty brackets mean that this is an empty list. So this is the first way. This is how you create an empty list that we can add to later. This next example is showing how you would create a list that already has 3 items on it: Bob, Bo, and Barry. So these are 3 names that are already on the list. You don't have to use this line first. This line can stand by itself and it will create a list with 3 items on it and save it in the name players. And then once you've created the list, you can use a loop to actually add things to that list. So in this case, you would be adding 10 names to the list. You would ask the person to input their names, and then you would add each one to the list of players. So let's keep in mind that if you're starting from a blank list, at the end you would have 10 names on that list. But if you were starting from this list with 3 names on it, at that point at the end you would have 13 names on your list because you'd be adding names after Barry on the list. And then in AP pseudocode, we use very similar syntax to Python, but of course instead of an equals assignment operator, we use this arrow, and then instead of a for loop, we would repeat 10 times and then get the input into the variable name, and then this is how you do append. So you'll notice that again in Python we see this dot operator. The dot operator is going to be how you call a method on a list. So lists, like strings in Python, come with lots of different methods that you can use. Here's a short list of some of the most important ones that you might see, but there are lots of methods that come built in with the list. And again, if you want to understand and learn about each of these methods, the best way to do that is to experiment with them, play around with them, and then also go and look at the API, look at the documentation, and read about what each of these methods might do. Some of them are going to be fairly obvious. Things like remove, things like count, things like reverse. Sort might be a little more confusing, but it's important, even if you think you know what the method does, to go look it up, read the documentation, and then play around with it to confirm that you understand how it's going to work in different situations. So let's try out some of our list methods together.
We are going to look at some practice with lists. So let's jump right into it. I have a list of players at the top: Alice, Bob, and Carl. And then down below I have numbers, just some random numbers: 2, 5, 1, 8, 2, and 7. So one of the most important things that we have with lists is being able to add items to it. Now that method is append. So if I want to simply take my players list and I want to append or add on an extra player, let's say someone on my team joined later in the season and I want to add them to my roster, and I add Dave onto it. Now to check to see if this worked, let's go ahead and reprint out my players list to see what the result is. So when I run my code, I see Alice, Bob, Carl, and now Dave is on the end. Now something different happened here that we didn't have to do, or we did have to do back when we used strings. So for a string, when we appended something, or let's say we capitalized it or uppercased it, we had to then save it back to and apply it to our original variable. But for lists, we don't have to do that. The reason, strings are immutable, which means they cannot be changed and maintain that change. We have to override it. However, lists are mutable, which means any change we do to them automatically takes effect. So this is a nice feature of lists, the fact that I don't have to save it back to the original list. So I have players, I have Dave that I added. Let's say I want to allow someone to type in their own. So let's do for I in range, let's do 3. So we want to allow someone to add 3 players to this list on their own. So this is where I could do, let's say, person. Let's go ahead and get an input from the user, enter a player name, and then with that person that they typed in, I'm going to, let's borrow this code here, I'm going to append whatever person that they added in. And so it should do this 3 different times. And so if I run my code, enter a player name, so let's go with Greg, enter a player name, and one by one as I'm typing them, it should be adding them to my list. Let's type in Denise, and then we can see it added Greg, Steve, and Denise. Now, I'm a guy that likes my roster to be in alphabetical order. So when other people added Greg and Steve, that was all fine until we added in Denise. And I don't like that. So in Python, there's a very simple way that we can change this. If we do players dot sort. And so this will automatically sort my list of players. And so if I run it again, let's type in Greg, Steve, Steve this time, and Denise. And you can see that it added all of them, but then it resorted my list to be in alphabetical order. So there's other things. We had clear, we had pop, we had reverse. So all of those things also can apply to this list as well. Now let's just look at the numbers list. So for instance, if I want to look at this one and do some of the same things, maybe I want to numbers.count. Count allows me to count how many times something occurs in my list. So maybe I want to count how many 2s there are. Okay, well for this one, it does count it, but since it's not actually changing my list, this is an instance where I need to save it back to the variable count, and then I can output that value appears count times. And so if I run this, that value appears 2 times. If I type in, let's say, a 7, which only appeared once, appeared 1 time. And if I have something that didn't appear at all, like a 0, we see it appeared 0 times. And so now the flexibility that we have with this is, what if I allow the user to choose what we are checking? So if I go ahead and add in value equals input, and what number are you looking for? And I allow the user to enter this. Now it should be an integer, so let's go ahead and typecast this as an int. And now instead of searching for what we type in, we can search for the value the user typed in. And now I have a dynamic program. So what number are you looking for? A 5. That appeared once. What number are you looking for? A 2. That appeared twice. What number are you looking for? 100. That appeared 0 times. And you can do the same thing with our players list. You could prompt the user to type in a name, and it will search through my list and see if that player is on my roster. So kind of cool, all the different things that we can do with lists. Just like with strings, there are a bunch of them. And the only way to understand how they work is to just create a program like this and play around with those different values.
So as I mentioned with strings, lists have a lot of useful methods that we can use that were already written for us. However, there will come a time when you can't find a method to do exactly what you want to do, and instead you need to traverse or iterate over the list to perform an operation. So you want to know, and this is how you yourself are going to eventually be able to write methods for other programmers to use, because eventually you want to be able to contribute your own code to these programs. So traversing a list is an important step in being able to operate on each of the items in that list. In Scratch, we were able to traverse a list by using an index variable and repeating for the length of that list, and then we could, print out each item by referencing it through the index. In Python, we again have this nice system for us that says for, and then person is a variable in players. Remember I said that anything that is iterable can go into this place right here? That's a string, that's a range, and now we see that a list also is iterable, and person is the variable that's going to take on each value in that list. In AP pseudocode, we also have a for loop kind of like this one that's called the for each loop. And the structure of that is going to be for each item in players, and then you have your curly braces and the code in the body. So that's how you traverse a list in Python and AP pseudocode. Now it's time to move on to the exercise. The exercise for this lesson is going to ask you to write some programs or write some code to process lists of names and numbers. All right, you're going to have a chance to work with all the different list methods that you've learned and to perform a variety of operations on these lists. Okay, so you're working with lists of names and numbers, and make sure you use your references or come back to this video if you need a reminder for how to call or use the methods that come with the lists in Python.